Geometry, note section 3.6, slopes of parallel and perpendicular lines. Postulate 3.3, two non-vertical lines are parallel if they have the same slope. So ignore the non-vertical lines for a minute. It's saying that lines are parallel if they have the same slope. The reason it says non-vertical lines is because vertical lines have undefined slopes. You can't compare them. So what happens if you have vertical lines? Any two vertical lines are parallel, and any two horizontal lines are parallel. Postulate 3.4, now we'll get into that in a minute. Let's check this out. Write the equation of a line that's parallel to y equals negative 3x minus 5. And goes through the point negative 1, 8. So this picture has nothing to do with this problem. Ignore that picture. Write the equation of a line that's parallel to this line and goes through this point. Well, what two things do we need to make an equation? We need a point and we need a slope. Then we can write the equation in point, slope form. Do we have a point that our line's going to go through? We sure do. It's negative 1, 8. Write the equation of a line that's parallel to the given line and goes through this point. The slope of the line that we're given is the coefficient of x, negative 3. A parallel slope, according to the postulate 3.3 up above, will have the same slope, also negative 3. So in point slope form, this is going to be pretty easy. We're going to have y minus 8 equals negative 3 times the difference of x and negative 1. Finished. Done. Nothing more to do. Moving on. Are the following lines parallel? Why or why not? Well, the easiest way for us to determine this is to put these equations in slope-intercept form. Then we would clearly know what the slopes of each of them were. We could then compare the slopes. If they're the same, the lines are parallel. If they're not the same, the lines are not parallel. I'm going to subtract 3x from both sides of this equation. I'm going to divide both sides by negative 1 to get rid of this times negative 1 here. The slope of this line is 3. This next one, if we were to add 6x to both sides and divide both sides by 2, both sides meaning each term, we would find that this line also has a slope of 3. Are the following lines parallel? The lines are parallel. It says why or why not? Because they have the same slope. Postulate 3.4. Two lines are perpendicular if and only if their slopes are negative reciprocals. And then we're told vertical and horizontal lines are perpendicular. So let me explain what a negative reciprocal is. If you're given 3 over 2, the negative reciprocal, you take the fraction and you flip it over, then you change the sign. Another example, let's say we had negative 1/2. Negative reciprocal would be 2. Change the sign, was negative, now it's positive. Reciprocate it, 1 over 2 becomes 2. Another example, let's say we had 7/4, it's going to be negative 7/4, negative reciprocal. Here's a picture. I don't remember why I put this picture in here. My apologies. But it does show that we have perpendicular lines. Let's look at the original picture we had here as well. These two lines appear to be parallel. The reason that we could tell for sure is if we went down 2 and to the right 3, this slope's negative 2/3. For this one here, if we go down 2 and to the right 3, we also have a slope of negative 2/3. So in this picture, line 1 and line 2, which it's written here in the picture, they're parallel to each other. And this one here, the picture on the right, looks like this goes up 2 and to the right 3, positive. It looks like this one goes left 2 and up 3. So its slope is negative 2/3. Scratch that. Negative 3/2. Those are negative reciprocals. We can conclude from this that L1 is perpendicular to L2. Let's look at a word example. Write the equation of a line that is perpendicular to y equals x plus 2 and contains the point 15, negative 4. Well, what two things do you need to make an equation? Well, Timmy, you need a point and you need a slope. What would you do with a point and a slope? You would put it into point, slope form. The point, it says it contains 15, negative 4. That's our point. To find the slope, well, if you look at what we're given this equation in slope-intercept form. The equation of this line is 1. A perpendicular slope, if you take 1 and reciprocate it, you still get 1. If you change the sign, you get negative 1. This is going to be y minus y sub 1 equals m times the difference of x and x sub 1. So it's y minus a negative 4 equals the slope of negative 1 times the difference of x and 15. Finished. That's our equation of our perpendicular line. Number 4, are the following equations perpendicular to each other? Why or why not? Just like the other one, we want to figure out what these slopes are. We want to get them in slope-intercept form. This first one is already in slope-intercept form. Its slope is 4. The second one, if we subtract 8x from both sides, then divide each term by negative 2, we get this equation. Its slope is also 4. Are the following perpendicular? These lines are not perpendicular. Why or why not, it asks? Because the slopes are not negative reciprocals. All right, to the back. A rectangle is a quadrilateral. It means it has 4 sides. Each side is a segment, and the segments intersect each other only at their endpoints. A rectangle is a quadrilateral and has opposite sides that are parallel and adjacent sides that are perpendicular. So a quadrilateral, 4-sided closed figure, and it's telling us what makes it a rectangle is opposite sides are parallel and adjacent sides are perpendicular. Is quadrilateral ABCD a rectangle? Why or why not? Let's list these ordered pairs. Let's put it into our picture. Gives us a spatial sense of what's happening. A is 1, 1. That would be here. B is 5, 3. That would be here. C is 7, 1. That would be here. D would be 3, 0. That would be here. Does this appear to be a rectangle? Certainly doesn't appear to be a rectangle. This is drawn to scale. In fact, we know it's not a rectangle. That's not good enough. That will never be good enough. We're supposed to explain why or why not, so we can't just say, well, it doesn't look like one. Using the definition of a rectangle that we're given above, a rectangle is a quadrilateral that has opposite sides parallel and adjacent sides perpendicular. So if we were to find the slope of these sides and compare them, we could tell if this was a rectangle or not. You have to be careful. I can't just write slope, so don't write this, is change in y over change in x and go to town. Because I'm finding multiple slopes. When I'm finished with this, I want to know which slopes that I have found. We need to find the slope of segment AB. We need to find the slope of segment CD. Those are opposite sides. Those should be the same if it's a rectangle. We need to find the slope of AD, and we need to find the slope of BC. Those two should be the same if it's a rectangle, because they're opposite sides. In addition to that, when you compare the first two with the last two, the first two should be negative reciprocals of the last two. If all those things happen, it's a rectangle. If they don't, then it isn't. So to find the slope of segment AB, we're going to do change in y over change in x. Our y values for A and B are 1 and 3. Our x values are 1 and 5. That's going to give us negative 2 over negative 4, which is 1/2. CD should also be 1/2. This is going to be a rectangle. CD, give myself a little more space here. Every time you use slope formula, you're required to write down the formula before you put numbers in. Change in y over change in x. CD has y values of 0 and 1 and x values of 3 and 7. It's going to be negative 1 over negative 4, which is 1/4. We can stop right now. We don't have to find any more slopes. A quadrilateral, a rectangle has opposite sides with the same slope. We just found opposite sides have slopes that are different. So it couldn't be parallel. So it doesn't matter what happens with the rest of them because it doesn't fit the definition. Question was, is this a rectangle? Let me mention one more thing that I failed to mention. It says is quadrilateral ABCD a rectangle. Well, how does that matter the way that's named? You're supposed to start at A, go to B. Once you get to B, go to C. Once you get to C, go to D, and then go back to where you started. Is that a quadrilateral, first of all? That's the question we should have asked ourselves first. If the answer is no, we can stop. How could it end up not being a quadrilateral? Well, if you connect your points and it ends up like this, that's not a quadrilateral. Anywho, question was, is this a rectangle? So we need to say ABCD is not a rectangle. Then it says why or why not? Because opposite sides AB and CD, notice how specific I'm being, are not parallel. Are the other two sides parallel? They could be, but the fact that these ones aren't automatically negates this, and it could not be that. So finished. Two more examples. I don't think I need to do these. If you want to do these on your own, you can. The answer that you get for this one could be something like y minus negative 5 equals the slope of negative 9 times the difference of x and 1. If you want to try it on your own, you can. You should get this for your answer. And this one down here, if you want to try on your own, you should get y minus 2 equals negative 1/3 times the difference of x and negative 3. Thank you for listening and watching and smelling and tasting. Thank you for touching the video.